Good morning, everyone. Today we explore a revolutionary shift in the automotive sector, the rise of electric vehicles or EVs. These vehicles aim to drastically reduce our environmental footprints through innovative automotive technology. Unlike conventional vehicles powered by internal combustion engines that use gasoline or diesels, EVs are driven by electric motors and rely on advanced lithium-ion batteries for energy storage. This paradigm shift is not merely technology evolution, it represents a crucial strategy in our global effort to mitigate climate change and foster a sustainable future. We embark on a journey through the transformative landscape of electric vehicles, a pivotal innovation in our quest for sustainable transportation. This shift is not just technological, it's a vital comeback for our global strategy to combat climate change. EVs such as Tesla Model 3 or the Tesla models or the Chevrolet Bolt exemplify this shift by combining high efficiency electric motors with advanced battery technology to dramatically reduce the reliance of fossil fuels. The transition is supported globally by initiatives like European Green Deal, which aims to promote cleaner car emissions and significant reduction in urban population by 2030. The research is driven by the goal of providing a comprehensive analysis of electric vehicle market, understanding its current trajectories, forecasts its growth. We deal with the complex interplay of technology advancement, consumer behaviors, and regulatory framework that shape EV landscape. The study extends beyond simple market analysis. We explore the broader environmental benefits of EV, particularly focusing on their potential to reduce urban air population and their integration into emerging smart grid technologies. These insights aimed at empowering policymaker, manufacturer, and consumer with the data needed to make informed decisions that could accelerate the global transition to electrify mobility. For the comprehensive analysis, we collected a rich dataset encompassing various dimensions. We examined industry reports from microeconomics, trends, and regulatory impacts, and surveyed consumer data to understand buying behaviors and preferences. Social media analysis, particularly of platforms like Reddit, provided us with unfiltered consumer opinions and sentiments, offering a ground level view of public perception. The global research offered data collection facilitated by advanced APIs such as News API ensured that our findings were not geographically solved but reflective of global transition toward mobility. The extensive data creation involved advanced data mining technologies and machine learning algorithms and text mining algorithms to ensure the accuracy and relevance of the insights we derived. Where we also identify several key trends that are shaping the future of electric vehicles. One of the most striking is the rapid advancement in the battery technology, particularly in the terms of energy density and cost reduction, as in the latest release from Panasonic and Samsung. Moreover, the increasing availability of fast charging infrastructure such as Tesla supercharger network is elevating range anxiety, making EVs more appealing to the average consumer. Additionally, the shift towards the ride-sharing and autonomous fleets is expected to accelerate the penetration of EV in a major urban center around the world. The environmental analysis beyond the direct reduction of tailpipe line, we assess the full life cycle carbon footprint of EV, considering everything from the mining of materials for batteries to the disposal and recycling processes. Despite some concern over the sourcing of material like cobalt and lithium, technology advancement and improved regulatory frameworks are enhancing the sustainability of the process. Furthermore, as a renewable resource like solar and wind becomes more prevalent in energy mix, the indirect emissions associated with EVs continue to decrease. Consumer adoption of EV is influenced by a complex interplay of factors. Our study indicates the growing consciousness around the environmental benefits of EVs, coupled with increasing economic incentives such as tax breaks and low maintenance costs. For example, the introduction of models like Ford Mustang Mach-E has expanded the market research to more lifestyle-oriented consumer, demonstrating that EVs can cater to diverse consumers' needs and preferences. However, the need of comprehensive education incentives about EVs benefits and technology is clear, as a misconception of knowledge gaps remain the significant barriers. The electric vehicle revolution reverberates across a diverse stakeholders from automotive and energy providers to policymakers and consumers. For automakers, the transition to electric mobility represents both strategic and imperative and an opportunity for innovation and differentiation. Companies like General Motors, which is commitment to all electric future, are investing billions in electrification efforts to position themselves as a leaders in EV. Energy providers too are providing towards electric mobility, investing in charging infrastructure and renewable energy projects to support the growing fleet of electric vehicles. Meanwhile, the policymakers face the challenge of balancing economic incentives and regulatory frameworks to foster EV adoption while ensuring a fair transition for the traditional automotive industry. These stakeholder impact underscore the interconnected nature of the electric vehicles ecosystem and collaborative efforts from the required to drive sustainable energy change. So let us turn on the focus on the global landscape of electric vehicles, which showcase a diversified tapestry of adoption rate and strategies across the different regions. For instance, in Norway, electric vehicles constitute nearly 60% of the new car sale, a feat achieved through a mix of aggressive tax exceptions, free parking, and the use of bus lane. Contrasted with the United States, where incentives vary widely by state and overall market penetration is significantly lower. In China, the government push to dominate the EV sector is a part of its broader strategies and goals in technology and manufacturing supported by substantial subsidies and investment in charging infrastructure. These examples underscore the critical role of tailored government policies in categorizing EV adoption, illustrating how different strategies align with regional, economic, and environmental priorities. Advancement in vehicle technology continue to accelerate, bringing us closer to overcoming some of the longest standing barriers to widespread adoption. A prime example of this innovation is the development of solid state batteries. Companies like Toyota are at the forefront, aiming to commercialize this technology, which promises a higher energy density, faster charging times, and potential low cost. However, challenges remains particularly in the supply chain, where the demand for materials like lithium and cobalt is increasing. These materials are crucial for the battery production but are fraught with a geopolitical and ethical concern. Addressing these challenges requires a concentrated effort from the stakeholders across the spectrum to innovate more sustainable and efficiency solutions, such as recycling technologies or alternative battery compositions. Consumer education and engagement are pivotal in accelerating the shift towards electric vehicles. Despite the advancement and benefit associated with EVs, many potential users remain hesitant due to lack of understanding prevailing myths around EV compatibility, such as range anxiety. Initiatives like Electrify America, launched by Volkswagen, aim to bridge this gap through nationwide charging station and robustness education campaigns. These are completed by digital platforms that leverage social media and mobile apps to inform engaged consumer. For example, interactive apps that stimulate EV ownership experience or virtual reality setups at car shows allow potential buyer to experience the benefit of EV firsthand, thus demystifying the technology and enhancing consumer comfort with this technology. The future of mobility with EV at the helm promises to be revolutionary. Um, we anticipate a significant development in the battery swap technology, which could reduce the charging times to mere minutes. The integrating of EVs not into smaller grid technology also suggests that future vehicle will not only consume energy but also contribute back to the grid during peak times, a concept known as vehicle to grid or V2G systems. Additionally, the push towards autonomous driving technologies in EV will likely to change very nature of vehicle ownership and use, leading to more shared and efficient managed transportation. Emerging markets are seeing increased interest in EVs, potentially leapfrogging traditional vehicles usage to embrace cleaner technologies also. In conclusion, the transition to the electrified vehicles have multifaceted challenges that present unique opportunities. It is an essential component of our global efforts to reduce greenhouse gas emissions, enhance urban quality, and transition towards renewable energy. The parts will require sustained collaboration between governments, industries, and consumers. It will also necessitate continued innovation, technology, and infrastructure to fully realize the potential of electric vehicles. So, thank you for your attention. I look forward to any questions you may have, and I am eager to discuss this topic further.